Hey, so this video I am going to go over reflections on the coordinate plane. So we are working on transformations in this unit, and transformations can be translations, reflections, or rotations. So in this video I'm going to explain how to do reflections. So first thing is, if you think about what a reflection is, it's a mirror image. Okay, we usually think of a mirror when we think of a reflection. In math, what we're going to do is we're going to flip our shape over a line, over an axis. So if you look at the reflection, the word reflection, hopefully will help you remember that we want to flip over a, I'm going to say a line, or if you want to think of it like an axis, like the x-axis or the y-axis. So when we are doing a reflection, we're going to flip the shape over. All right, so let's start off with a triangle. So I'm not sure this is super focused, so let me just check the focus here a second. Get this to be where we can make it crystal clear. There we go. Okay, I think that looks better. All right, so let's start with, okay, I am going to just make a triangle that's kind of longer on one side than the other. Oops. And I'm going to label this A, B, C. All right, so for the first example, I want to do a reflection over the y-axis. So if you think about what that means that the y-axis runs right here. So this is our y-axis. So I want to reflect across the y-axis. So what that means is that if I'm going to use a piece of paper just to kind of show this to you. So if I trace this right here, just to make sure that I get it pretty close to perfect. So you can just watch what I'm doing right here. And then here is our axis, or our line, that we're going to reflect over. What that means is that this shape needs to, this shape, let me hold it still, needs to fold over the line, and it's going to end up being like that. So that's how we get a reflection. So we're going to flip this shape from this side of the line, flip it over to this side of the line. All right, now I know how to do that because however far it is on this side, it has to be the same distance away on this side. So let's say that, let's start right here. Let's say that this point B is at, let's say it's at -2, 7. Okay? So if this is 2 spaces away, then I know its reflection has to be the same distance on the other side of the axis. All right, so let's go to point A right here. Let's say this one is -4, 5. All right, so if this is this distance on the left, its reflection is going to be that same distance on the right. So here is A prime. And then if we look at this point right here, point C, let's say this is -2, 2. So if it's this far on the left, its reflection will be this far on the right. So now if we connect our points, we have the reflection of this triangle has been reflected over to this side. I didn't connect my points so good, but you get the idea. So now I can see that the distance right here on this side and this side is the same. The distance on this side and this side is the same. And the distance on this side and this side is the same. So this is a reflection over the y-axis. So reflection over the y-axis. All right, now let's look at what happens to our ordered pairs though. So this ordered pair right here, I called negative 2, 7. So if this is negative 2, 7, what is going to be the ordered pair for its reflection? So I want you to pause and think about that for just a second. Okay, since this point is 2 spaces to the left and its reflection is 2 spaces to the right, but it didn't change up or down, then I know that the ordered pair for B prime is 2, 7. All right, let's try point A. So if point A is negative 4, 5, what is the ordered pair for A prime? So since this is 4 spaces to the left, its reflection is 4 spaces to the right, which makes this ordered pair 4, 5. All right, so let's take a look at this one. If the ordered pair for point C is negative 2, 2, what is the ordered pair for C prime? If this one is 2 spaces to the left, its reflection will be 2 spaces to the right. So the rule for reflecting over the y-axis is the y didn't change, but the x is the opposite. So we went from a negative to a positive. We went from a negative to a positive. So the sign on the x changed, but the y stayed the same. All right, let's take a look at what happens if we reflect over the x-axis. So I'm going to move down here. I'm going to start with, let's do, I'm going to go this way, kind of for space. Make sure we can get this in the right place. All right, I'm going to call this X, Y, Z. And this time, I'm going to reflect over the x-axis. So I know that the x-axis runs left to right. So here is the x-axis. So now what I'm going to do is I want to reflect this triangle over this axis. So if I get my patty paper again, so I am going to just trace this shape right here, just to demonstrate, so you kind of have a visual idea of what's going to happen here. So this one is right here. So if I reflect this over this line, that means I should end up somewhere down there. All right, so let's try it. Let's move this so you can see. All right, since X is 2 spaces above, its reflection will be 2 spaces below. All right, the next one, Y is 4 spaces above, So its reflection should be 4 spaces below. Z is 2 spaces above, so its reflection should be 2 spaces below. And so now I can draw my triangle by connecting those points, and I have the reflection of this triangle over the x-axis to produce this triangle. All right, so let's pick some ordered pairs. So let's say this one is 3, 2. We'll say this one is 9, 2. And maybe this one is 5, 4. So I'm just making those up. Okay, so if the ordered pair for x is 3, 2, what's the ordered pair for x prime? Okay, well, I'm still going 3 spaces out, but instead of going 2 up, I'm going 2 down, so that should be 3, negative 2. All right, let's try point y. So if the ordered pair for y is 5, 4, its reflection should be what point? Well, instead of going up 4, I'm going down 4, but I'm not moving right or left. All right, and then for z, so the ordered pair for z prime. Well, again, if z is 2 spaces up, its reflection would be 2 spaces down, but I'm not moving right or left. So when we do a reflection over the x-axis, so reflection over the x-axis, if you notice, the x values stayed the same, the y values changed signs. So the x stays the same, but the y changes. All right, that takes care of the basics on reflections. So we will practice some more once you get to class.